Welcome to our revision session on acceleration. So we're going to be doing this question in this little video here, and the whole key here is to revise the concept of acceleration and how to do calculations with the acceleration equation. Now remember that when we're talking about motion, we need to say what direction things are traveling, because with acceleration, with velocity and displacement, they're all vectors. They've all got arrows on the top, which means their direction matters. Okay, so when we talk about this, and since we're talking about acceleration here, we need to stipulate a direction. So let's just say that we have east and north. And of course that would be south and west. So there's our directions, or our coordinates. Now the question says a motorbike accelerates from rest to 30 meters per second. So let's draw a diagram, because you always want to draw a diagram to help you problem solve. And it doesn't matter how poor the diagram is. There's mine, looks like a bike, but anyway, it's a motorbike. Accelerates from rest. So if it's from rest, it means it's not moving. So its initial velocity is equal to 0 meters per second. And it says it accelerates until it reaches a velocity of 30 meters per second. So along this distance here, when it gets to here, okay, so initial velocity, final velocity. It says it took 4 seconds to do that, right? So 4 seconds, the time to accelerate from 0 to 30, it took 4 seconds. And the question just says, how fast did the bike accelerate? So it's a pretty simple question, but let's see if we can break it down for you. So we've got acceleration. Now the acceleration is the change of velocity. So it's the change in velocity over time. Now when we talk about a change is the final, take away the initial. So here it's going to be the final velocity, take away the initial velocity over time. And in physics we like to use u to represent initial. So let's fix that up. So we've got our final there, v minus u, and then over t. So there's our equation, okay? And we can put our little arrows over the top there. So that's what we're using, and it says we want to calculate the acceleration. So we've got no rearrangement of the formula here, so it's pretty straightforward substitution. So let's substitute this in. So the final velocity is 30 meters per second. Take away the initial velocity, which is 0 meters per second, divided by the time. Well, it took 4 seconds. So pretty much you're just going 30 divided by 4. That's all you're doing really. And when you do that, you get 7.5. And the units are meters per second squared, right? So we've got meters per second here, and we've got another second in the denominator. So that means per second per second. So that's meters per second squared. So the units for acceleration is meters per second squared. Is that our final answer? Well, not quite, because this is the magnitude. Then of course we have to have a direction. And so what's our direction here? Well, it's going towards the east. So you'd go 7.5 meters per second squared east. And so now there is our complete acceleration answer. Pretty quick, pretty simple, pretty easy. If we were to change the question and make it a little bit more challenging, we could change the numbers around, and they could ask you to find what t is. So they might sort of say, okay, if they were to rewrite the question, they could say, well, a motorbike accelerates at 7.5 meters per second. So a motorbike accelerates, and we're going to say they're giving you the acceleration now at 7.5 meters per second squared from rest to 30 meters per second. Now they're going to get rid of this last bit because they want you to get the find of time. So we change the question now. How long? So here they're asking for the time. So you would do the same thing. You would start with your equation. So, all right, so there's our equation there. And so now we have to rearrange that to find t, the subject of the equation. So we times both sides by t, because over here we divided by t, so we need times, which is the opposite. So when you times by t, they cancel. and then we get TA equals V minus U, and then we want to get rid of the A, so we divide both sides by A. The A's cancel, and so therefore our final equation is T is equal to V minus U over A. Alright, and then we just substitute in the values. So the final velocity was 30, running out of room, so let's do it over here. 30 minus the initial, which was 0, divided by the acceleration, which was 7.5. And you should end up with the same answer because we use the same numbers, right? But the whole point of that was to show you how to change the equation around. And so your answer would be 4 seconds. That's how long the bike was accelerating for. Simple acceleration question. Hope that makes sense. Go through it all. Make sure you understand what's going on. Don't forget your units. And don't forget your direction when it's a vector. Alright, see you in the next video where we do another question.